What's up everyone, this is Philip from Moralis.io. In this video I want to show you what cloud functions are in Moralis. I want to talk about why we need these cloud functions in order to build powerful dApps, and also how we actually build them. And this video is sort of a follow-up to the video where I showed you how to build a dApp using Moralis, because we left off there having built this dice game, this coin flip game. Let's see, like this. This is what we built, where you can play heads or tails, but we're working on our way into building something like this, where we not only have the actual flip functionality, where we can enter an amount, play heads or tails and flip, but also we have these statistics of top winners, top losers, these leaderboards, biggest bets placed. So this is sort of a follow-up to that. But let's start talking about why we actually need cloud functions, because you might be used to building dApps with only a front end in JavaScript and then your smart contract, which is built in Solidity, for example. But the problem with that is that you can't really do any powerful queries that way. If you want, for example, to have a leaderboard like this, or you want to have all the tokens that your users currently hold in their balances, or you want to know, you want to sort something, you want to get the list of your users with the highest sorted on the amount of tokens that they have, for example. Or you want to filter a list of your users where you only want the users that have X amount of tokens or X amount of ETH. You want to do filtering, you want to do sorting, you want to do aggregation, you want to do statistics, anything that requires you to do bulk operations on data, not just individual requests like you can do with web3.js, for example, when you do it on the front end. But anytime you want to aggregate data or work with bigger data sets, or you need data from the blockchain, like gas spent or token balances, those sort of things, we need to be able to do some logic on the database and from the server side. And that's what cloud functions are. Cloud functions are what allows us to take the data that is in our database. For example, in this case, the dApp we built, we have a bunch of events in our database. And these events, they get added as soon as someone plays this game. They do a flip. We add an event in the database with how much they betted, how much they bet, and if they won or lost, and what side of the coin they chose. And that's when we use cloud functions. We use cloud functions in order to then take that data that's in the database here and produce these statistics, these leaderboards. And we need cloud functions in order to do that, because we need to be able to aggregate this data to see, okay, how many bets have this user done? We need to be able to do those sort of database operations, and the cloud functions allow us to do that. And now we're going to get into how we actually write them. And if you're familiar with database programming group 4 from SQL or Mongo or any other non-SQL database, then this will be easy for you. If you're not, then it might be a bit harder, but it's not rocket science. You'll get up to speed pretty quickly. It's written in JavaScript. So if you know JavaScript, that will help you out. Yeah, let's get into that, how we actually write cloud functions. And we start in our server list here in Moralis. And if you haven't gotten your invite yet, make sure to sign up to the beta list over at moralis.io, and I'm sure you'll get an invite very, very soon. But once you have that and you have some servers up and running, then, and of course you also need some data in your database. So I suggest you also watch the previous video where we actually built a dApp, so they actually get some data into your database. But once you have that, you can click on cloud functions in order to bring up the cloud functions code panel. And here is where we actually input our cloud functions. And we start off by this. We always start off by this. Let's see, I can make this bigger. Let's see, can you see that? Yes, that's sort of visible. And you always start up with this, moralis.cloud.define, and then here you have the name of your cloud function. So let's just put this test to begin with. And then the second parameter is the actual function that we will run, which will, in most cases, or I think in every case, be asynchronous. And then you always take one parameter, which is the request. So here, if you're calling this from your front end, which you will be doing, then you can provide inputs here as well. So that's important. But in the case we're going to do here, we're not going to have any inputs from the actual user. We always start off by defining and creating our query. So we'll start by creating the actual query object, and we do that with new parse.query. And here we specify the name of the table that we want to work with. So in this case, my table and the table that we built in the previous video was named flips, because that's where we save all of the coin flips. Okay, and now we can start providing actual filtering and sorting restraints on this query, because we could just fetch this query right away, which would just get all of the objects from all of the rows from the flips table. So if we were to try that, we would write const result is equal to await query.find, and this would go out and it would get all of the rows in the flips table, and it would save it in the result variable, and then we can return result. Okay, that will give it back to the front end where we're calling this function from. Okay, so we'll be calling this from our JavaScript front end, and then we'll get back result. But let's say we want to put some limitation on this query. So we want to say, for example, that okay, we only want the flips that resulted in actual win. Then we can say query dot equal to, okay, and we would for example say that the win column, so the last column here to the right was called win, so you would specify as the first argument here the name of the column. So the win column is going to be true. Okay, that will now restrain this query to only returning rows where win is equal to true. And then we run query.find and we return the result. So should we try this out? Okay, so now we have a very simple cloud code, but still very powerful filtering here. So let's click save file, and this will now install that cloud function here on the server, and that can take a few seconds. But in the meantime, we're going to go back to the game that we created here and make sure that we actually make a call to this function to see the result, because there is no way for us to get the result directly here in the Moralis dashboard. We need to query the function from our code. So let's just do it here after we have signed in. So in the login function at the end of here, we will get results equal to await moralis.cloud.run, and here we provide the name of the function that we want to run, and we named it test, I think. And then here we provide the arguments that we want to input, but we don't want to input anything, so we leave it empty. And then we that's it, and then we can just console log the results. And then in the end, we will make sure to add these to the front end, we'll populate the tables and so on. But now let's just play around with the cloud functions for some time here. So save that, and let's go ahead and check out our website. Now we just console log this, so we'll have to look in the console. Sign in with MetaMask, and I'm gonna do that. Now we see these two objects here. So apparently we've had two flips that have been actual wins. And if we want to get more data out of this, we can look inside attributes, and here you will see that the bet was 200. We chose tails and we won. And the second object here, if you look under attributes, we bet 400 and we won and played heads. Okay, and now let's check in our actual database. So this is the database that corresponds to this app. Previously I was showing you more data, that was a previous app, but here we have the real data in our app that we're using right now. So we have 4 flips total, and they're all made by the same user. And let's see here, and we have 2 wins indeed. Okay, 2 wins right there. All right, so the query actually works. We got the ones that were winning flips. Now if we go back to our cloud functions again, we can of course set this to false, we get the other 2 and so on. So now we've done a very simple query. Let me share a few more simple things that we can do. You can also say, for example, that I want query dot greater than. You can say that win should be greater than 100. I do not want any wins that are smaller than 100. I want all of the wins, sorry, not win, this was bet. We want the win to be true, but I want the bet to be bigger than 100 or bigger than 500, whatever. Then you would get all of the winning bets that were over 500. Okay, and then you could, for example, also sort the result here. So if you want to sort it, you can say query.ascending or query.descending descending, and then you can say, okay, I want us to sort this descending based on the bet size also. So then you would get the biggest bets at the top of the array, 0 index, and then it will descend from there. So all of these are possible queries you can make. You can also combine this here after you fetch the result. You can combine this with whatever JavaScript you want down here. But these are some basic queries that we can do. Now I want to get into some of the more advanced queries that we will use here. So let's say that we go back to the query here where we just filter out the wins. Let's say we want to sum up all of the betted amounts, all of the winning bets, and compile it into one number. See how much has been won in this betting Dapp, okay? In this coin flip, okay? So we're going to sum up all of the amounts from winning bets. Now, how do we do that? In order to do that, we have to add an actual pipeline. And a pipeline is a concept from MongoDB, the database that is behind all of this. And it's a way for us to do multiple queries, and we can nest them into each other. We can do multiple ones of those nested queries as well. That allows us just to do more complex operations, similar to how you would do an SQL query, but in MongoDB. So we're going to create this pipeline, which is an array. Okay, and in this array, we can do multiple different actions, right? So each action we can group within as one JavaScript object. One that we're going to use a lot is the stage called group. And what this does is that it groups together all of the different rows in the database according to one specific column. So let's say we wanted to group, let's say we want to calculate, which we're going to do later on, the sum of all the bets grouped by an address. So that grouped by the address. So then we will get back one sum of all the bets, but for each specified user. So we've taken the sum, but we have grouped it for each specified address. And there are similar commands in SQL where you group by a specific column or a specific property. So here we can choose to group it by a specific property. So if we have 4 bets divided by 2 addresses, it will summarize and group them into these 2 specific addresses. So let's just try first of all to do one group, meaning that we group all the bets together into one sum. Okay. First we have to specify which which property we want to group by, and that we do in the object ID parameter. So here we specify, for example, okay, I want to group by the user address, or I want to group by their name or their email. If we specify null, then we will group them all together. So we're going to do that, okay? And then the second field that we want to return, because these are fields that we will return the total sum. And here we'll use a function in the MongoDB library of functions for their database, and or they're called operators, I think. And we're going to use the sum operator. So we write it with $$sum. All of the actions that we take within a pipeline have to be denominated like this, with a $, and then sum. And then within what is it that we want to summarize, so within these curly brackets, we specify what we want to sum, and we want to sum the actual column that is $, bet. Okay, so this is how we specify an actual column within the pipeline. We also have to do $, bet. And this would work except for that bet is an actual string in our database. So bet is a string, so we need to convert that into an integer. So we need one more operator here in our, where is it? Here. It's here. We need one more operator before we do the sum. So we need to do $to int of bet. So when you look at this, you need to start from the inside out. First, we convert the bet column, each row of the bet column, into an integer. Then we sum those together, we summarize them, add them together, and then we group them together. In this case, we don't group them by any characteristics or any property, we just group them all together, and then we return them back. So that's what we're going to do now. Instead of doing this query.find, we'll run query.aggregate, and we input the pipeline that we want to aggregate them using. And then we need to input, whenever we do the pipeline, we need to input this property here inside. Come on. It's called use master key is equal to true. There we go. As the second argument. And then we can return the result. Let's save this file and let's see if we wrote this correctly, because we will get an error back here if something doesn't compile in our script. We'll get an error here, but we also might get runtime errors when we actually run the script, when we call it. But let's see if it works. We get some error, let's see. Trying to figure out what I did wrong here. The toInt operator doesn't actually require any of these brackets. So that was my bad. And you can see that in the documentation. Let's try that again. There we go. Now let's go ahead and try this by opening up our web page and refreshing this. Let's see, sign in, see if we get this query. Here we go. Total sum 600. Is that correct? Well, yeah, we had one winning bet which was 400 and another winning bet that was 200. Those were our two only winning bets. Okay, so that's cool. Now we've had now I've showcased how we can summarize and add together different rows in our database. Now the real property here, where we had top winners, this actually uses this aggregation where we summarize all of the different wins, but we group them by address. So that's what we do here. We group the result by address, and that's very easy to do with this code. So if we instead choose to group by object ID /user, that will group it by the user address. Okay, so this is now the biggest winners. I'll name this query. Okay, because that's what this now is. We've done one of the 3 queries that I had in my original demo site. So now we can change that here. So we instead call biggest winners. Okay. And now you can also think about, okay, what do we need to do if we want this to be the opposite? If we want to summarize all the losing bets, so that we create this biggest losers table as well. Top winners, top losers. And then finally, we'll talk about how we do this biggest bets placed. Let's see if it had compiled. There we go. So what if we also want to do biggest losers? Well, we'll copy all of this because it's very similar. And we name it biggest losers. But instead of querying that win should be true, we say that win should be false. The rest of it is exactly the same. We summarize bets and we group them by user. We save that, and now we can, in our code, try to get both of these. So first we'll console log biggest winners, then we'll console log, we'll say like this, biggest winners, and here is biggest losers. Now these will be grouped by address. The only problem now is that we only have one user that has been playing, so we might need to change that. But let's try this. Here we get 2. So total sum of winning trades was 600. Total sum of losing trades was also 600. Is that correct? Let's see here. We had 400 plus 200 and 500 plus 100. Yes, so they're actually the same. And you can see that now they are grouped. So they come in an array where each object is the total sum for the specified player. Now let's go ahead and play with a new address. So let's go ahead and open up Ganache and add another address. So let's take the second address here, press the key, import this private key into MetaMask. Now I'm in my new account, and I just need now to go ahead and sign out. We actually don't have a sign out button. Let's see if I sign in now. I'll still be signed in with my old account, I think. Or maybe not, let's see. So I'm gonna bet with 1,000. No, this is the old account, I think. Yes, I don't want this account. So I actually need to sign in with the other account. So let's go ahead and build a sign out button real quick. We'll add a button somewhere here, login button, log out button. Or actually, let's place this at the bottom. I'll place it in a new div so that it doesn't interfere too much with the layout here. And then in our main.js file, we need to add a handler for that. Logout button, we're going to trigger the logout function. The logout function we can build here. Async function logout. Await moralis.user.logout. And then when that is done, well, we can leave it at that for now, but we can refresh the page and then, or we can alert logged out. I'm also going to remove the logged in alert because that is disturbing me a lot. Okay, so now we can actually log out. You see how beautiful design this is? Let's see, logout is not a function. Oh, it should be log out in camel case. So log out with a capital O. Let's go ahead and log out. Logged out. Okay, so now I can have my newly selected account. Let's see. Now I can choose to connect my new account. Like that. Sign in with MetaMask. Sign in. There we go. We do have another video, hopefully when you're watching this, on the on-account switch event, so that you can do this automatically, so you don't have to do this log in, log out thing. But now let's bet with the second account. So 1,000 way, play tails, confirm. I lost. Let's play with 2,000. We can do this pyramiding tactic. That way you can never lose. They say you lost. 4,000. Play heads. Confirm. You won. Boom. All right, so now I'm break even with my fake way. So okay, let's play 8,000 again. You won. Okay, so now I'm definitely winning a lot of stuff. So let's check the database again. Refresh. Now I have a lot of stuff here. Okay, let's run our let's refresh the page and log in to run our cloud functions again. And now you see we get two different totals for the different addresses for the different users. So one has won 600, the other one has won 12,000, which was the recent one, and the same person has lost 3,000, so the net is 9,000, and the other person is just the break even. Okay, so that's the power of grouping by user address, and it's all made possible because of this Moralis database and the cloud functions. Very, very powerful. Now the final thing that is left to do in terms of cloud functions is this biggest bets placed. We want to get all the bets, or rather the top 10 bets, and we want to sort them by the bet size. Okay, how do we do that? Well, let's go into our cloud functions and add a third cloud function. I'll copy all of this again. Let's see, now we have 3. We'll call this biggest bets. And now we don't want this filter here on win, because we want all the bets. We just want the biggest bets. And we're also not going to use group anymore. We're going to use something else that's called project. And project, it just reshapes the rows. So if we say, for example, query.select, which means we select which columns we want this to return. We want user, we want bet, and we want win. So this means that we get the address, we get the amount that was betted, and we get if it was a win or a loss. Now project can reshape this, because what we want to do is we need to convert bet into an integer, and then after, well, that's everything we need to do in project. And then after that, we're going to do a sorting call as well. So we want to project. That means that we want to change bet, so that bet is, instead of being just a bet string, we want it to be, well, what this was right here. Let's see, this, okay? And that's really the only thing we need to modify. But we also need to tell the project command that, okay, I want win to be included as well, and I want the user to be included as well. So then you put them as 1. If you wouldn't want user, then you say -1. But if you want the user column to continue to be passed on to the next step in the pipeline, we need to say 1 and 1. And after this, we can do another step in the pipeline. So here, it means that this first step will run first. Then the second step here, we can run another command in the pipeline, which will run after the project command. And this is the sort command. And here we specify that how we want to sort the result. And we want to sort it by the bet column. And we want to sort it descending, which we do by saying -1. And then finally, as the third stage in the pipeline, we want to run the limit command, which will limit the amount. It will take the top 10 basically. So first we will sort descending, and then we'll take the 10 most highest rows, and we'll send them back, okay? And that's it. That's all it takes, okay? Let's hope I made this correct. Save file, and let's see if that compiles. Okay, so no errors there. Now, let's do this query in our app as well. So we want to run the biggest bets. Gonna be equal to biggest bets. There we go, console biggest bets. And let's see if that works. Sign in. Now you see we get the 2. First biggest wins, biggest losses, and now biggest bets. And these should be sorted now. 8,000, 4,000, 2,000, 1,000, 500, 400, 200, 100. And we only have 8, but because we limited it to 10, but we just have 7 in our database, or 8. So it won't give us any more than that. But you can see it is ordered, and it provides us the user, if it was a win or not, and the size of the bet, exactly what we wanted. So all that's left now, because now you know about Cloud Functions, and I'll leave links below to the documentation where you can learn about all of the different pipeline stages that are available, all the different functions, all the different commands, and so that you can learn about that on your own. But feel free to play around in Moralis, request the beta, you'll get the beta very soon, and then you can log in and play around with this with yourself, because this is truly groundbreaking for Web3 and for Dapps. So make sure that you're ahead of the pack. But with that done, it's only the UI that's left, okay? So since this is just normal Bootstrap tables, I won't be going into as big of a detail, because that's nothing new. You can learn about that from any YouTuber. But I'm going to quickly code through how we bring these tables to life so that we can finish this Dapp once and for all. So let's create a new div. Above the logout button, we're gonna set this as a row for Bootstrap purposes. ID should be statistics. We might need to use that later. And then in here, we're gonna have 3 Bootstrap columns. So call MD6. That's what I had in my previous one. So each one of these will take up half of the screen, since it's 6. If you don't know about Bootstrap, you can learn about that somewhere else. And then in here, we're going to have a heading. So H3, let's say. First, we're going to do top winners. And then we'll specify that we want a table. So it'll be class table. We'll give it the ID top winners. Okay. And in here, we're going to have a table header. And in there, we'll have a table row. And in there, we'll have two actual columns. Let's see here. Scope, column, and this will be address. and we'll have another one that is total way 1. So this is for the top winners, the addresses that has won the most. We'll have these two columns, address and total way 1. That's what we'll populate it with our with the data that we got from the cloud functions. All of this will copy down here to the remainder, and this will be top losers, and then this will be biggest bets placed. And for top losers, the columns remain the same, address and total way lost. But for the third one, we had 3 things we wanted to populate. First we had the address, then we had the bet size, let's say way, and then we had one more column, which was if it was a win or a loss. Win, loss. Okay, all that's left now is to populate this. So let's say on login, we already call all of these. Okay, now, well, we can keep console logging them, but after we have gotten all of these, we need to add them to the table. And how do we add them to the table? Well, we need a function for this. We're gonna call it add row to table. Well, before we do that, let's just quickly inspect what we've been doing here. So now you can see we have these 3 tables, but no contents. So let's go back. Let's see, do we actually have the container? So this row and this button should actually be within the container. There we go, that should look better. Yeah, there we go, we have the spacing and everything correct. Now let's build out the add row to table function. But this is pretty standard JavaScript. So first we're going to create a new table row. Document.create element. It's going to be a tr element. And by the way, this needs to take the table ID that we want to add it to and data. Did we actually give these IDs? Top winners? No. Top losers. And then finally, biggest bets. They have to have unique IDs, of course. And then the data will be the data that we get from these results. We will run add row to table for biggest winners, or did we call it biggest winners, right? Top winners. Top winners, and then the data will be biggest winners that we got from the cloud function. So we're going to loop through that data, data for each. And for each, so this will be like for each column that we get in the data, we want to create a new column. So let new column be equal to document.create element, and that's a td element. And then we want to set the new column, that inner HTML, meaning the content of that element, we want to set to the data that we get here. So let's say we input here the biggest winners. Then the first element here will be the address, and we will set the new column to that, and the inner HTML of that will be the address. The next time we come into here, it will be the amount. Then the inner HTML of that new element will be the amount. And for each one of these we create, we will add it to our table row with append child for the new row. And then finally, once we have created the entire row, we will add this to the table. So get element by ID. For the table ID, we'll append a child, which is the table row. So we create the row, we add all the data to that row, we add the row to the table that we specified here with the data that we inputted here. I'm sorry if it was a bit too quick here, but we need to wrap this video up, and you can pause the video and see step by step what I'm doing if you need more time. All right, so now all that's left is to run this add row to table top winners, and to do the same thing for biggest losers. and for biggest bets. Let's see if I actually managed to get this together correctly. Sign in with MetaMask. Well, something went wrong. New row is not defined. Let's see what I did. Ah, here should be a new column. There we go. Oh, not really. Let's see what we did here. Let's console log the data here and see what's up. I'm just missed something here, and I'm not sure what. All right, we have two. I mean, each one of these is an array in and of itself. So, so we'll have to do this for every row. So we want one row for each, winner. We're going to do this for all of this. Let's check now. And then I need this now to be an array. So row dot object ID and row dot, what did we call this? Total sum. Total sum, same thing here. And then here we had row dot user, row dot bet, and row dot win. This is it. Let's see. Here we go. Here we go. So this is correct. Top winners. This is sorted in the wrong way, and this as well. So it might just be that we have to flip something around. Oh, so we actually did not sort these in our cloud code. We could add, just like we did down here, sort. We could do the same thing up here, but we didn't. So, well, I can show you what it will look like. Let's see, group will look like this and like this. We want to sort on total sum. And yeah, total sum there as well. Okay, and save that. Let's see. But in the meantime, we could admire what we accomplished here. So now we have our DApp here, not super beautiful, but I mean, it looks okay. And then we have our aggregated data here, top winners, top losers, and the biggest bets placed. And this was created in, just a few hours, all in all. And we don't have to run our own Ethereum node, don't have to run our own database, all is serverless, everything is set up for you. I mean, can it get any better? Let's see if this finishes running. It's really great, and I encourage you once again to play around with this and to use this in your dApps moving forward, because you never know when you're going to need things like this. Any sort of filtering, high scores, or aggregation, statistics, it's just fantastic. So no errors there. Let's see if we update this now. Now it's sorted as well. All right, perfect. Let's wrap up there. So thank you so much for watching this tutorial. And I want to wish you the best of luck moving forward with your own code and your own dApps. Please sign up for Moralis and check out the links below. Also, if you want to learn more about smart contract programming, JavaScript programming, dApp programming, make sure to check out the Ivan Tech Academy where I teach. And I'm looking forward to seeing you in a future Moralis tutorial, and check out our other videos, like the video, subscribe, all of that good stuff, and have a good day.